Hello, this is Dr. Jagannadha Rao, Head of the Department Mathematics and Applied Science, Kalinga University, Raipur. Earlier module, I have discussed about regression analysis and properties of regression analysis, uses of regression analysis, and what are the assumptions required to use the regression analysis. All those concepts we have discussed. In module 2, I want to discuss about probability distributions. So, in probability distributions, what is the distribution? There are two types of distribution: frequency distribution and probability distribution. In frequency distribution, it is a listing of observed or oblique actual frequencies of all the outcomes of an experiment that actually occurred when experiment was done. So that is nothing but frequency distribution. In probability distribution, in the sense, it is not actually happened. Probability means we are estimating. If the experiment will be done, then it may be a output, it may be a result, right? For example, in tossing of a coin. So in tossing of a coin, we will expect either head or tail. It is a probability. We will predict. In a cricket match, as well as before starting the match, they will toss a coin. In that, they will predict. Both the captains will predict. It may be head or it may be a tail. Based on that, they will select the decision. They will take the decision either batting or bowling. So probability distribution, it is a listing of the probabilities of all possible outcomes that could occur if the experiment was done. Now, there are types of distributions in the statistics: observed frequency distribution and probability distribution. Observed means it is an actual, and in that the probability distribution, in the sense, it is a occurrence, chances. So in the frequency distribution, in the sense, it is a actual observations. It is obtained by actual observation. And in this probability distribution, in the sense, which are mathematically deduced under certain assumptions. So in the probability distribution, there are two types: discrete probability distribution and continuous probability distribution. Means in the discrete distribution, random variables can take only limited number of values, means number of heads in tossing of two tosses. In the continuous, in the sense, random variables can take any value, means decimals also it will accept, fractions, decimals, and the height of the students in the class, marks and the marks of the students in a class. These are all continuous distributions. Age, weight, these are all continuous distributions. Now, in the discrete probability distribution, there are a lot of distributions are there. Mainly, we will discuss about binomial distribution and Poisson distribution. And continuous probability distribution, we will discuss only one, normal distribution. What is binomial distribution? Binomial. In name itself, it's suggesting bi, in the sense two, yes or no, true or false. So it is a binomial distribution is a discrete probability distribution, means it will take that discrete values from 1, 2, 3 like that. We cannot say in our house or in our family 3.5 people are living or 2.5 people are living. We will say either 2 people are living or 3 people are living. So this the binomial distribution was first discovered by James Bernoulli. It is used in those scenarios where the outcomes of an experiment are in the form of success and failure, the set of only two alternatives, hence the name is binomial. For example, a new drug is introduced and an experiment is conducted to identify whether the drug will cure the disease or it does not, means whether this drug is a success or failure. So similarly, tossing of a coin, 10 times if you are tossing, either 10 times, 3 times head or 7 times tail, or 5 times head, 5 times tail. Like that, you will just estimate it. So many examples are there. And where you will apply this binomial distribution? The number of trials are finite, then we can apply this binomial distribution, and only two possible outcomes which are mutually exclusive. So in mutually exclusive, in the sense, the happening of one event prevents the happening of other event. Head in tossing of a coin, if you are getting head, in the sense, it is preventing to get the tail. So each trial is independent. If I am tossing a coin in 2 times, first time I am getting head, means it is not necessary to second time tossing is also getting the head. Second time it may be a head or tail. So the probability of success is same in each trial. Every trial has a equal chance of possible outcomes. And the properties of this binomial distribution is, the main parameters of this binomial distributions are n, p, and it is called, that's why, biparametric distribution. Constants of binomial distribution, mean is in np and variance is npq. Mean is always greater than the variance. Now, second distribution is Poisson distribution. It is also a discrete probability distribution. It is discovered by French mathematician Dr. Simon Denis Poisson. So it is used in those scenarios where the probability of happening of an event is very small. That is, the chances of the happening of event is rare. This means that probability of success is very low, very small, and the value of n is very large. If I am tossing a coin in 1000 times, means then n is very large and success is very low. For example, in a manufacturing of a company, if a company is manufacturing a lot of 1000 items at a time, in 1000 items only defectives may occur 3 to 5 items. If it is 3 to 5 items, means here Poisson distribution is applying. Why? Because the number of items are 1000 and chances of fault is 3 to 5 items. So probabilities are calculated for a certain time period only. For example, the probability of defective items in a manufacturing company for a month. In a month of manufacturing, they will manufacture a lot of items. For example, milk production. They will manufacture around 1000 packets per day or 5000 packets, milk packets per day. Out of that, they will test whether that product is maintaining proper ratio or not. Next, what are the characteristics of this Poisson distribution? It is a discrete distribution and occurrences are statistically independent. First event and second event, both are independent. Mean of occurrences in a unit time is proportional to size of unit. For example, if 5 in the first year, then second year is 10 only. In third year, 15. So mean of occurrences in a unit time is proportional. That is, and mean of this Poisson distribution is NP. Standard deviation is root NP, and it is also a right skewed distribution. And where we will apply, if the number of trials, that is n value, is large and the probability of success P is very small, then we will apply this Poisson distribution. For example, accidents, road accidents. For example, one particular area in a particular road, the accidents are happening. Every year they will take the data and they will calculate if the accidents are more happening, then based on that they will take the precautions, keeping of one board or by using one pedestrian road or what is required, foot over bridge is required or flyover is required, whatever is required, based on this data only they will take. Past experience shows that the average are 2 traffic accidents on a particular stretch of a road every week. So there is a necessity to take major actions on that particular road. So another major property is main parametrics. Main parametrics are, it is called a uniparametric, only one parameter, that is M we will use in the Poisson distribution. Constants of this Poisson distribution is mean is equal to variance. Now another distribution is normal distribution. Most widely used continuous probability distribution used to study the behavior of continuous random variables like weight and height. It was first discovered by English mathematician Abraham D. Movie. So normal distribution is also known as the Gaussian distribution, as it was later discovered by Laplace and Karl-Gauss. The graph of a normal distribution is called normal curve, also called bell curve, bell-shaped curve. The curve is in the bell-shaped. This left tail as well as this right tail, it never touches the baseline. It looks like touching the baseline. This is baseline. It looks like touching the baseline, but it never touches the baseline. The normal distribution is a probability function that describes how values of a variable are distributed. Normal distribution is defined and given by the probability function. Now, a standard normal distribution is that normal distribution whose mean is 0. A standard normal distribution always having the mean value is 0 and standard deviation is 1. So, standard normal distribution follows the graph of normal distribution on two factors, the mean and standard deviation. The mean of a distribution determines the location of the center of the graph, and the standard deviation determines the width of the graph. All normal distributions look like a symmetric bell-shaped curve. If the shape bell-shaped, the smaller the standard deviation. If the standard deviation is small, then peak will becomes very high. If the standard deviation is very high, then the peak will becomes very low. So, based on the standard deviation, the peak of the normal distribution we can estimate. So, it is a continuous probability distribution. Random variables can take any value within a given range, height, weight, marks, etc. Developed by 18th century mathematician as Carl Gauss, so also called as a Gaussian distribution, and it is a symmetrical unimodal. Its main feature is only one peak it contains, and symmetrical, as already we have discussed. It means mean, median, mode all coincides at the center of the graph, and left side as well as the right side are same mirror image. X-axis represents random variable like height, weight, etc. and y-axis represents its probability density function. Area under the curve tells the probability. The main feature of this is normal curve is area under the curve is 1. So, it telling that probability is equal to 1 in the sense it is a best estimation. So, the total area under the curve is 1 means 100%, and only two parameters, that is mean and standard deviation. So, mean and standard deviation, maybe it have same mean or different standard deviation, or same standard deviation, different means, and different means and different standard deviation. In all aspects we can go through this normal distribution. Another feature is 68, 95, 99 rule. So, most of the data, 68% of the data is lies at the frequency, that 68% of the data frequency will be at near the mean of the curve, bell-shaped curve, and remaining 95% is so between mu minus 2 sigma 2 mu plus 2 times of standard deviation, mean plus 2 times of standard deviation to mean minus 2 times of standard deviation. 95% of the data will be occurs in this, and mean minus 3 times of standard deviation to mean plus 3 times of standard deviation of the data lies 99.7%. Means between 99.7 data is between mean minus 3 standard deviation to mean plus 3 standard deviation. That's why it is called 68, 95, 99 rule. Now, area under this curve, mean plus or minus 1 standard deviation, mean plus or minus 2 standard deviation, and mean plus or minus 3 standard deviation. Thank you. Okay. Hello, this is Dr. Jagannadha Rao, Head of Department Mathematics and Applied Science, Kalinga University, Raipur. Module 3, Testing of Hypothesis. In earlier Module 1 and Module 2, I have discussed about the regression analysis and different probability distributions. Now, the testing of hypothesis is another important concept in statistics. So that I will discuss in this current module. So hypothesis is nothing but an assumption or a statement that may be or may not be true. Null hypothesis, there are two types of hypothesis, null hypothesis and alternative hypothesis. For example, one particular statement and I am going to test whether that statement is true or false. In null hypothesis means the hypothesis that are generally proposed with the intent of receiving of rejection for them are called null hypothesis. Alternate hypothesis. Rejection of null hypothesis leads to the acceptance of alternate hypothesis. There are mainly two types of tests, one-tailed test and two-tailed test. One-tailed test, there are left side tail, as well as already in the previous module I said, and the baseline, the normal distribution curve should be a bell-shaped curve, and this left tail and this right tail, if it is towards the left side, then it is called a left tail test, and if it is towards the right, then it is called as a right tail test. Only either the test is used one-tailed only if the null hypothesis gets rejected, means not accepting. We cannot say it is a rejected, we are not accepting the null hypothesis. When a value of the test statistics falls in the left side or right side, based on that we will decide whether it is a left or right. Hypothesis. In hypothesis testing, after deciding of null hypothesis and fixing of alternate hypothesis, we will start hypothesis testing by using the proper and suitable statistical tests, parametric test and non-parametric test. So before going to that, I will discuss about what is parametric test and non-parametric test. In parametric test, Z test, G test, T test, F test means ANOVA, and in the non-parametric test, chi-square test, U test and H test we will use. What are the parametric tests in the sense? First, it assumes the distribution to be normal. The data should be normally distributed. In the non-parametric tests in the sense that does not assume distribution to be normal. Means data is no need to be a normally distributed. And make assumptions about the population. In parametric test, we will make assumptions about the entire population. And here in parametric tests, we will use the parameters such as mean, standard deviation, etc. are used. In applied, in case of quantitative data, in case of variables, scale of measurement is either interval or ratio scale, and uses mean as the central tendency value, and more powerful, parametric tests are more powerful. That's why we will maximum use this parametric test, and it has a less robust about the parametric. And in the coming to non-parametric test, it is already I said data it should not be a normally distributed and does not make any assumptions about the population. No such parameters mean or standard deviation we will not use in this non-parametric test. Applied this non-parametric test if the data is a qualitative data. So quantitative in the sense quantities, numbers, facts and figures. In qualitative in the sense characteristics. For example, person's characteristics, right? Qualitative data. In case of attributes, and scale of measurement is either ordinal scale or nominal scale. Uses the median as a central tendency and mean is the central tendency for parametric test, and it is very less powerful as compared to parametric test, and it has a more robust. Why? Because they are solid in a broader range of options. These are the main steps. Now, in testing of hypothesis, first you will state the null hypothesis and alternative hypothesis. After that, you will set up the criteria for the decision, means level of significance. How much accuracy you are expecting, level of significance that is, and collect the data, means select your sample. If I want to collect the data of entire Raipur region, Raipur, Durg region. Like that, collect the data. Decide which test is to be performed for your data. Compute the test statistic and find the critical value of that and compare the critical value with the test statistical value. Make a decision either you should accept or not accept the null hypothesis. These are the steps, major steps in the testing of hypothesis. One by one, I am going to discuss null hypothesis. What is null hypothesis and alternate hypothesis? Null hypothesis is a statement which assumes that there is no significant relationship between the variables. It is to be tested for its verification and validity. And a alternative hypothesis, a statement which assumes that there is a significant relationship between the variables. Alternative is giving there is a significant relationship between the variables, also called research hypothesis. Alternative hypothesis is also called research hypothesis. Next, set the criteria for a decision level of significance. For example, 5% level of significance means I am expecting 95% of the data should be accurate and 5% may be a error. Or it is set prior to conducting the hypothesis testing. It can be set most of the cases 5% or lower. If 5% of level of significance indicates that 5% risk concluding that there is a difference exists when there is no actual difference. There is no actual difference, but we are concluding that 5% there is a actual.